Okay, we're going to talk about the mole and mole conversions. All right, so I've taken a couple slides that were in your original discussion out just for simplicity's sake. So if you're working with your original discussion notes, you may see a couple things missing, but same information. Okay, so what is the mole and why do we use it? Now you know just from living in the world that a pair is two things. You know that a dozen is 12 things. Okay? And we use those to simplify. We have a pair of socks, we have a dozen eggs. But when we're talking about atoms, a pair or a dozen doesn't really work very well because we have so many atoms in a single sample. So when we talk about atoms, we'll talk about a mole of atoms. And a mole is 6.02 times 10 to the 23rd things. Okay, so if I have a mole of atoms, that means I have 6.02 times 10 to the 23rd. If I have a mole of pennies, I have 6.02 times 10 to the 23rd pennies, and I am very rich but also crushed by copper. And if I have a mole of elephants, I have 6.02 times 10 to the 23rd elephants. Works the exact same way as a pair or a dozen, but atoms are tiny. So we have to use a really big counting number to represent them. Okay, a pair or a dozen is just not going to cut it. And we could talk about the individual number of atoms, but the scientific notation would get really cumbersome to deal with. So it's just easier to talk about them in terms of moles. Okay, so molar mass can be found from the periodic table, and it's the sum of all the masses of atoms in a molecule. The units are grams per mole, which we can abbreviate as grams G per mol. That's not much of a mole abbreviation, but it's the best thing we've got, so we're just going to deal with it. All right, so some examples. If we're just looking at an atom, like for example copper, we would just get the mass right off the periodic table, so 63.55 grams per mole. But if we're looking for something like carbon dioxide, we'd have to add up 1 times the mass of carbon plus 2 times the mass of oxygen, and we would get 44.01 grams per mole. Okay, so try this first example, calculating the molar mass of calcium nitrate. I would pause and then press play when you're ready to check it, and while you're paused, you can look at number 2 if you want to give that a shot as well. Okay, so when we calculate the molar mass of calcium nitrate, you really have to be careful here and remember that the 2 applies to nitrogen and the oxygens. So I have 1 calcium atom with a mass of 40.08. I have 2 nitrogens with a mass of 14.01 and 6 oxygens with a mass of 16.00. Okay, so the molar mass of calcium nitrate is 164.10 grams per mole. Now let's look at this next problem. I obtain 0.2 moles of an unknown substance and find that the mass of those 0.2 moles is 6.4 grams. So what is the molar mass? Well, we know the units of molar mass are grams per mole. So if I take the grams that I have and divide them by the moles, even though it's not 1 mole, if I divide through, that'll give me the grams per 1 mole, right? So I would get 32.0 grams per mole. So this is a good example of a time when the units can really tell you how to solve the problem. So use that. All right, so through further testing, I find that the substance in the previous problem is a diatomic element. Which diatomic element is it? Okay, well, we know that the mass of that diatomic element is 32, and we know that it's something 2. All right, so there's 2 atoms, and the total mass is 32. So if I want to get the mass of 1 atom, I just have to divide that by 2, and I'll get the mass of 1 atom is 16. By looking at my periodic table, I see that oxygen has a mass of 16, so it must be O2. Okay, so let's talk about doing some mole conversions. All right, this is a really important slide, and you may find yourself referencing this a lot when you work on the homework. Okay, so we have mass in grams. We have moles. And we have particles. And so the number of particles, those particles could be atoms, could be molecules, saying molecules when we're talking about ionic compounds. Since they don't actually exist in individual molecules, they exist in a crystal lattice, we say formula units. It's technically more correct. Okay, so let's look at how we convert between these. If we want to convert between mass and moles, we need to have something that relates the grams to the mole. So, fortunately, we do. We have molar mass. And the units of molar mass are grams per mole. And you'll recall from just a minute ago that this comes from the periodic table. Okay? If we want to convert from moles to particles, this is where we're going to use that number that we talked about. It's called Avogadro's number because he's the guy who came up with it. And it's 6.02 times 10 to the 23rd particles per mole. Okay, so we have to think about how we're going to get from point A to point B anytime we're doing a conversion. If I'm going to go from moles to particles, well then I'm going to use Avogadro's number. And if I'm just doing that conversion, it actually doesn't matter what the substance is, okay? Because Avogadro's number is not dependent on the substance. If I want to go from mass to moles, I'll use the molar mass. And if I want to go from mass to particles, I can't do that conversion in just one step. Okay, I'll have to first convert to moles and then convert to particles. So let's look at a little summary of some of this. If I have 1 mole of aluminum, to get its mass, I would use the periodic table and see that it's 26.98 grams. And I'm going to also, every time I put a unit, I'm also going to include a label here saying what the substance is. That can be really, really important in the next topic. Not so much right now, but it's good to get in the habit now. Okay? Now, 1 mole of anything has 6.02 times 10 to the 23rd particles. So in this case, I have 6.02 times 10 to the 23rd atoms of aluminum. Okay? If I have half a mole, that means the mass is divided by 2, so I have 13.49 grams. And again, my number of atoms is divided by 2, so 3.01 times 10 to the 23rd atoms of aluminum. Okay? If I have a mole of zinc, its mass is going to be different because it has a different mass in the periodic table. So it's 65.39 grams of zinc. But the number of particles is not going to change because that is not dependent on the substance. So it's still going to have 6.02 times 10 to the 23rd atoms. And if I have a mole of water, to get that molar mass, I'm going to have to add up 2 hydrogens and 1 oxygen from the periodic table. So I'll get 18.02 grams of water. But again, a mole is defined as 6.02 times 10 to the 23rd particles, so I'm still going to have 6.02 times 10 to the 23rd, but this time it'll be molecules of water. And if you want to abbreviate molecules, you can just write cules. Don't write molec, because it looks too much like moles. Okay, so the trick to all of this is when you start to do these conversions, you have to think of molar mass as a conversion factor. So we know that it's 18.02 grams per mole, but when you see this, think 18.02 grams of water equals 1 mole of water. I know that might seem like a really small and kind of silly distinction to make, but when you think about it that way, it's easier to flip it in the direction you need it. Okay, so let me show you what I mean. Let's say we want to figure out how many moles there are in 9.01 grams of water. Okay, well I know I'm given 9.01 grams of water, and I want to find moles. It can also be really helpful to underline what you're given and circle where you're going, or something like that, some system that works for you. All right, so I'm given 9.01 grams of water, and I'm trying to find moles of water. All right, so I'm going to set up my dimensional analysis problem. And I'm going to take my grams and move them down. Now I have to ask myself, can I convert to moles? Do I have a factor that relates grams and moles? Well, sure I do. It's the molar mass. Okay? So then I have to ask myself, how many grams of water are in a mole, or how many moles are in a gram? Well, I know from here that 18.02 grams of water is equal to 1 mole of water. So here I put the molar mass in the denominator, right? Because I need the 18.02 to stay with the grams and 1 to stay with the moles. So my gram units cancel out and I'm left with moles. So I get 0.500 moles of water. And I took it to that many significant digits. Since I started with 3, I need to have 3 in my answer. And remember that the leading 0 doesn't count as a significant digit. Okay, so I want you to pause and do at least the first example. We haven't really gone over molecule conversions or an example yet, but you could try the second example too if you feel pretty comfortable with the dimensional analysis. And you can go back to that slide that relates them. So when you're ready to see the answer, go ahead and press play. Okay, so the first example is pretty similar to the one we just did. It says how many moles of water are in a water bottle that contains 500 grams? All right, so I'm given 500 grams and I'm trying to find moles of water. Okay, so I have 500 grams of water. And the decimal point there means that those trailing zeros are significant, so I have 3 significant digits in that number. Okay. I'm going to draw my dimensional analysis, take my upstairs unit and move it down. Okay, and can I convert grams of water to moles? Sure can, I just have to use the molar mass. And I have a conversion factor written out right there. There are 18.02 grams of water in 1 mole. There are 18.02 grams of water in 1 mole. Grams cancel out, I'm left with moles, which is what I want, and the answer is 27.7 moles of water. All right, so let's look at this next example. How many molecules of carbon dioxide are in 6.23 moles? Okay, so I start with 6.23 moles of CO2. And I'm trying to find molecules. I'm going to abbreviate this as cules just for space. Okay. Now, you can go back to that previous slide and I can ask myself, all right, can I convert from moles to particles? I sure can. All right, so let's take moles and move it down. And then let's put particles here. In this case, we're talking about molecules. All right, so now you have to ask yourself, how many molecules are in a mole or how many moles are in a molecule? Okay, well, so if we go back to that previous slide, we know that a mole always contains 6.02 times 10 to the 23rd things, whatever those things are. So 1 mole contains 6.02 times 10 to the 23rd molecules. Moles cancel out, and I'm left with molecules, and I get 3.75 times 10 to the 24th molecules of CO2. Now notice, I didn't actually use the molar mass at all. So knowing that it was CO2 was sort of extra information I didn't need to solve the problem. That'll be there sometimes. Usually they won't just say molecules of some random substance. They'll specify a substance. That doesn't mean you have to use the molar mass. Okay, let's look at one last problem. This is how many aluminum atoms are in a piece of foil that weighs 2.55 grams. All right, so I have 2.55 grams of aluminum. And I'm trying to convert to atoms. Now, if you look back, you'll see that we can't go straight from grams to atoms, okay? So I'm going to draw my dimensional analysis, take my upstairs unit and move it down and say, okay, I can't convert grams to atoms, but what can I convert grams to? Okay, well, I can convert grams to moles. So I'll go ahead and do that first. I know from the periodic table that there are 26.98 grams of aluminum in 1 mole. Okay? Grams cancel out, and now I have moles. All right, now, can I convert from moles to atoms? I sure can. I just have to use Avogadro's number. So I'm going to take moles and move it down. And then I'm going to ask myself, how many atoms are in a mole or how many moles are in an atom? Okay, well, there's 6.02 times 10 to the 23rd atoms in 1 mole, because that's how a mole is defined. All right, so then I can multiply through everything in the numerator and divide by everything in the denominator, and I will get 5.69 times 10 to the 22nd atoms of aluminum. And we can kind of do a common sense check here, okay? We know 1 mole weighs 26.98 grams. That's less than 1/10 of that. So we would expect to have less than a mole of atoms, right? And that makes sense, okay? Do a lot of practice with this. Make sure you do the homework. Make sure you do the in-class practice if you haven't. And ask me if you have questions.